Welcome everyone. In this video I'm going to go through the maths involved with Heggerty task 438, but before we get started on that I would like you to pause the video and I'd like you to have a look at these, how many is it, 9 numbers here. They're already in order for you and I'd like you to draw a box plot for these 9 numbers. I'll let you pause the video, I'll let you have a go, and then you can resume the video and I'll show you what to do. Right, so what you need is the lowest one, the lower quartile, the median, the upper quartile, and the highest one, okay? So here's the lowest, so this one's already done for us, right? That's the lowest. And this is the highest. And we need to work out what the median is. Now there's only 9 numbers and we should be pretty good at this now. We would cross off till we get to the middle, and of course that's going to leave us with 11 as the median. So we've got the lowest, we've got the highest, and we work out the median. And then we need our lower quartile and upper quartile as well. So our lower quartile, well, it'll be, what would I do? I would cut the data in half through the median. I wouldn't involve this 11, I wouldn't include it. And there would be the lower half, which is 4 numbers, and the upper half, which is 4 numbers. And then the median of these 4 numbers would be 5, which would be the lower quartile there, halfway between 4 and 6. And the upper quartile will be halfway between 13 and 17, which is 15. That's the upper quartile. So what you need to draw a box plot, and what box plots give you, right? So if I give you a picture of a box plot, or you see a picture of a box plot in a question, what it's showing you is it's showing you the lowest, it's showing you the lower quartile, it's showing you the median, it's showing you the upper quartile, and then it's showing you the highest, okay? So we've got the lowest value is 3, the lower quartile is 5, the median, so this is just for my question here, right? It will be different for, obviously, for different numbers. The median is 11, the upper quartile is 15, and the highest number is 20. If I wanted the interquartile range, not that it wants it in this question, but if I wanted that, I would do the upper quartile, take away the lower quartile, and of course that's 10 in this situation, right? So there you go. Now how do we actually draw the box plot? Well, you put 5 vertical lines in, one at the lowest, one at the lower quartile, one at the median, one at the upper quartile, and one at the highest. So there'll be a vertical line at 3. There's not really any rule about how big you make it, to be honest with you, so I'm just gonna make it this big, like why not? So there's going to be a vertical line at 3, then there's going to be a vertical line at 5, then there's going to be a vertical line at 11, and what I do is I keep them lined up, I keep them the same size. There's going to be a line at 15, which is going to be our upper quartile, and then there's going to be a line at 20 for our highest value. And then what you do is you join the lower quartile to the upper quartile like that, and then you put 2 lines here like that. And so that's how you draw a box plot. That is what a box plot is representing. You've got your lowest and your highest, you've got your lower quartile and your upper quartile, and you've got your median. So if I just gave you this picture, I could ask you, what's the range? If I asked you for the range, you would do the biggest, take away the smallest. If I asked for the interquartile range, it would be the upper quartile, take away the lower quartile. And if I asked for the median, well, you would just literally read it off and you would say it was 11. So that's how you draw a box plot, and that's what the picture of a box plot is actually telling you. Okay, it's telling you those 5 bits of information. Now, I just want to clarify something about comparing 2 box plots that are next to each other, which is actually what one of your Heggerty tasks was about. So when it's asking which class did better or which class scored higher overall on average, it's asking about an average. So in that situation, you would compare the medians. So whichever class has the higher median, you would say did better on average, had a higher median. Of course, you have got to think about the context as well in a situation like that, because, for example, if it was a race and you asked which team did better, for example, or the whole class runs 100 meters and then 2 classes do this and you get the average times, in that situation the lower the median would actually be better. That's the point I'm trying to make. So of course in a test you want the number to be higher, but in a race you want the number to be smaller. So you do have to be aware of the context as to what would be meant by being better or not. So in that situation you're comparing medians, okay? Nothing to do with the quartiles, okay? Nothing to do with the quartiles at all. Where the quartiles come in is when you're asked a question about consistency. So if the class is very consistent, it will not be very spread out. And the interquartile range is a better measure of spread than the range. So let me say that again. The interquartile range is more complicated than the range, obviously. The range is just the biggest, take away the smallest. That's, generally speaking, quite an easy thing to work out. The interquartile range, you have to do a bit of work to actually work that out. But there are some big advantages to the interquartile range over the range. And that is, say you had the whole class get, say, between 40% and 50% right on a test. And actually the person who got the lowest score actually got 40. But you had one person in the class, one person who got 100%. But everyone else got between 40 and 50. So if I asked you about the range was 60, right? You would do 100 take away 40. But that's not a very good measure of the spread and consistency of the class, because it was actually just one person who was a bit of an outlier, didn't really fit with the trend of the rest of the class. If I asked you what the interquartile range was, you would get a much smaller number and a much truer representation of how spread out the values were in the class. So when the question is asking who was more consistent, it's whichever has the smaller interquartile range. So you looked and I know it's not easy to see on Hegarty Maths, okay? It's quite small on the screen. I totally accept that. But the method is you look to see what the upper quartile is, and you look to see what the lower quartile is, and you do that for both of them. So you work out the interquartile range for both of them. And then whichever one is smaller, that was the one that was more consistent. Okay, so I'll just make a little note of that. I'll use the same bit of paper even though you can see the writing through, because this is just a really quick little note. So more consistent is the same as having a lower interquartile range. It's less spread out. Whereas if you were less consistent, that would be a higher interquartile range, and that would be more spread out. And that is, and to be clear, that's literally the sort of language you would need to use in an exam if you had a question that was asking you to compare two box plots, which is a very common type of exam question. You would be almost guaranteed to get that on one of the 3 papers. So they would usually ask a question asking you to compare the median, and then there would be well, how it usually is they just ask you to compare the 2 sets of data, and it's worth 2 marks. And the first mark is you compare the medians, saying who was better on average, whether that means higher because it was a test or lower because it was a race or whatever it might be. That's something for you to work out. And then the other mark is to say which one was more consistent, and that's whichever one has the lower interquartile range. Right, hopefully that clears up box plots. Now I'm actually going to do a couple of questions from task number 438. just to show you how to do this. This is quite complicated to try to explain in a video. This is something where clearly being in a classroom, being able to ask people questions and people ask me questions to clarify things, obviously that is more ideal than me trying to explain this in a video. But I'm going to try my best. I'm going to try to give you the method so that you can actually do this and try to get a good score. And I will try to explain what's going on as well, but mainly I'll focus on the method. Okay, so I've got the first question here. It says, use the cumulative frequency diagram to work out an estimate of the median speed. Now, what I'm actually tempted to do, I can't be bothered really with overly editing the video, so you might just have to put up with this, is if I actually print this out, which if you have that option at home, by the way, that can be quite useful, because if you print it out, you don't have to copy it all down. So it's just going to print, and then I'll put it here, and then I can actually write on it. So while we're waiting for it to print, how is everyone? You should leave a like. You should subscribe to the channel. You never know what quality maths content you're going to miss out on. I might even play Hit the Button. I'm sure you'd love to watch me do that. Right, okay. So there you go. If you are lucky enough to have a printer at home, you can just print these out and then there's no awkward copying, right? So here we go. We really have the question in front of us. So here's the cumulative frequency diagram. Now let's actually have a look at what some of these coordinates really are. So we've got 0, 0. If I look at the scale, it's going up in tens along the bottom. So this will be 5, and then what's this? 6, 7, 8. So 5, 8. Then we've got this number here would be 11. And this would be 13. Now, I don't actually have to do this in order to answer this question. I'm just trying to provide you with a little bit of context here, because I need to make sure that we've got all the numbers clear. Now, if your question 1 isn't the exact same as my question 1, obviously feel free to just be focused on this question here that's on your screen. Anyway, let's keep going. So this is, what's this? This is 35. And if I go all the way along, 27. And 41, 40. Right. So the Y number is how many there were less than the X number. So let me put that into a bit of context in this question, okay? So this is the Y number. And when you read this number off the graph, that's how many there are in terms of the frequency less than the X number. So that sounds a bit complicated, but let me talk about it with this graph, okay? So it doesn't give you any kind of context about where the data came from. This must have been a bunch of cars, I would guess. I mean, it could be anything, right? But these are the sort of speeds a car might do. And it's asking about the speed. So a bunch of cars have had their speed measured, maybe past a speed camera or something like that. And then they would have been grouped. And there would have been, I guess, 0 to 5, 5 to 11, 11 to 20, 20 to 35, and 35 to 41. Okay, so the cars were grouped like in one of those grouped continuous data tables. You would have had a 0 to 5, a 5 to 11, an 11 to 20, a 20 to 35, and a 35 to 41. So that's the first thing, and we could do that we could work that out for any cumulative frequency graph. And now I'll ask the question, how many cars were doing less than 41? So how many cars were doing less than 41? So remember, a cumulative frequency graph is telling you how many did less than a specific value along the x-axis. It's all about being less than a value on the x-axis. So let me ask the question again. How many cars were there who were recorded doing less than 41 miles an hour? So I go along to 41 miles an hour on the x-axis. Remember, on the x-axis is what's being measured. And I go up and I go along and I say, right, there were 40 cars. There must have been 40 cars altogether. So I'll just kind of fit it here. So there were 40 cars. And there were 40 cars altogether. That's not very neat. Sorry about that. I'll try and be neater. There were 40 cars altogether. All 40 cars did less than 41 miles per hour. So this is maybe a little bit of a complicated question because the numbers are quite similar, right? 41 and 40. It's 41 is the speed that all the cars were doing less than, and there were 40 of them doing less than 41 miles an hour. Okay, there were 40 of them doing less than 41 miles an hour. How many cars were doing less than 35 miles an hour? So let's have a look. We go along the x-axis. And so, by the way, before I would ask you questions like this in class, I would be asking questions like what I'm asking now so that people got used to reading the information off of a cumulative frequency diagram. Okay, so just to be clear, there isn't really an option for that on Hegarty though, because there's only the previous task and then this task, right? There's not an in-between. So this is why I'm kind of taking my time here a bit. I'll put timestamps in again, so feel free to skip ahead if you want to, but I'm trying to explain what this graph is about. Hopefully you're enjoying it, or maybe you're getting bored at this point. Either way, keep going. So how many cars are doing less than 35 miles an hour? Right, well, let's have a look. 27 cars are doing less than 35 miles an hour. So 27 cars are doing less than 35 miles per hour. Okay, so there are 27 cars doing less than 35 miles an hour. So how many cars are there actually doing between 35 and 41? How many cars are doing between 35 miles an hour and 41 miles an hour? So there are 40 cars altogether, and 27 of them are doing less than 35 miles an hour. So how many are doing between 35 and 41? And not including 41 exactly. So all you do is you do 40 take away 27. Right, that number in the frequency table that you would have would be 13 for between 35 and 41. The way I figured that out is by doing 40 take away 27. So this distance here. And I could keep going like this. I'm not going to because it's going to waste too much time for the video. But I could keep going. So for example, now I could say how many cars are doing less than 11 miles an hour. So go along to 11, go up, go along, there's 13. 13 cars are doing less than 11 miles an hour, or were recorded doing less than 11 miles per hour. Now, I can actually ask this question for any miles per hour number, up to 41, obviously. I mean, I wouldn't ask about any more because the graph stops. So, for example, I could ask how many cars were recorded doing less than 26 miles per hour. So this is the question. 26 miles per hour. So how many less than 26 miles per hour? So, okay, I go along the bottom to 26. So there's 20, 22, 24, 26, 28, 30, right? Those bottom number, the bottom scale in this is going up in twos. So there's 26. And so I would go up to there, and then I would go along to the Y number, and it's 20, 21, 22. So I would say that there are 22 that are doing less than 26 miles per hour. I'll just literally read it off the graph. Now this is where I need to make an important point before I can now actually just answer this question, okay? And then I won't need to add any more. At the actual coordinates that are plotted, right, we know for sure that number. We know for sure it's 40 and it's 27 because those are where the coordinates are actually plotted. We would have gotten that information from the table. Do we actually know for sure how many were doing less than 26 miles per hour? So this is a question. Do we know for sure? 22 seems to be the answer, but is it guaranteed to definitely be exactly 22? You could pause the video and I could be doing this for ages, but anyway, look, you can pause and have a think. The answer is no, it's not guaranteed to be 22, okay? And so let me explain why. It's because between 20 and 35, we've got, what is it, 27, take away 19, which is 8. So there are 8 cars that we're doing between 20 and 35. So let me say that again. You can tell from this graph that there are 8 cars, which is told by the distance on this on the cumulative frequency axis. Okay, so for the cars that we're doing between 20 and 35. So for 20 there were 19 doing 20 or less. For 35 it's 27 cars or less, and 27 take away 19 is 8 cars that must have been doing between 20 and 35. But here's the point. We don't know for sure exactly what speeds those cars were doing. They could have all been doing 20. So that would be 8 cars doing 20, right? That would be 8 cars doing 20. They might have all been doing 30. They might have all been doing 30. We don't know. When we start grouping data together in those grouped tables, which is where this picture's come from, when we start grouping data together, we lose that detail. We don't know exactly within the groups how they are spread out, how they are distributed. So this answer of 22 is our best guess. It's an estimate. And that's why it uses the word estimate in the question. We are going to estimate the median. We're going to estimate the median. This is how we do it. It's much easier if you can print it out. I won't lie to you. Much easier if you can print it out. But you can also print screen, put it into Paint or something like that, and draw a horizontal line and then a vertical line, and you can measure it that way as well. Okay, so it is possible to do it without printing. You could also draw this out on your own squared paper if you really wanted to as well. So this is how you do it. There are 40 cars altogether. That is not difficult to see. And if you had a different question, you would just look to see what's the biggest number on the y-axis. Okay, it's 4. I mean, I know it goes up to 45, but in terms of the graph, it's 40, right? So there were 40 cars altogether. I know it doesn't actually say cars in the question, but I'm just going to pretend it's cars, right? There were 40 of them. Now, the median would be the halfway number, and it's the best estimate we can possibly have. So from 0 to 40, halfway is 20. So this is for the median. I go halfway in this situation from 0 up to 40. I will do another question. I won't go go on about it half as long as I've gone on about this one. I will just simply answer it. But yeah, we go to 20 on the cumulative frequency. Okay, so that's what we do. We go to 20 on the cumulative frequency. So there we go. 20 is halfway. It's not halfway on the speeds. It's halfway in terms of it'll be the 20th car, right? It'll be from 0 to 40 halfway. It's going to give us our best estimate for the median speed. So one way to not actually make the mistake of ever going halfway along here is if you want the median speed, you're going to end up drawing a line going down that's going to give you your answer on the speed axis, which means you need to start over here to do a horizontal line first. So you do the horizontal line first in this type of question, okay? So because it's the median it wants, I go to halfway, which in this situation, halfway between 0 and 40, halfway between 0 and 40 is 20. So I go along, and I go down. And because Hegarty, I think overall is probably not giving you really harsh questions, it actually comes down to exactly 22 on that axis. So I know it says give your answer rounded to 1 decimal place, but I don't think we have to in this question.